Hello everyone. Good evening. My screen is visible. So can we start today's session? Okay. So we start. So okay. So this is the question number one for the week 6. So the question one is a signal xt is equal to 2 cos 5 pi 1040 10 to power 40 voltage applied to an FM modulator with the sensitivity constant of 10 kilohertz per volt. Then the modulation index of the FM wave. So basically in this question we have to calculate the modulation index. We have a xt is given. We have a kf sensitivity constant. So please try. Question is clear. Okay. So please try. There we have to calculate modulation index. I'm giving you a hint. We have a message signal with that having a message AM. From there you can calculate FM, or we have a KF. Just apply the formula of the modulation index for the FM. Okay, right. We will wait for others' response. Everyone got the answer? We have a KF, AM, and FM. Okay. So we go for the solution. Answer will be a part, that is 4, and this is the explanation. Okay, so basically we have a message signal that is 2 cos pi into 10 to power 10 to power 6 60, and kf is given 10 kilohertz per volt. Generally for the calculate the modulation index in FM we use that formula, kf am upon fm. Kf is a 10, am is a 2. Okay, 10 came in 10 kilohertz, and fm is the, we can calculate the fm from there. So we will compare from the 2 pi f. So from there we will get 1 by 2 into 10 to power 4. After solving you will get answer 4. Is this clear? The question number 1 is clear. Okay, so next question number 2. Question number 2 is our 10 megahertz carrier is frequency is modulated by a sinusoidal signal of 500 hertz. The maximum frequency deviation being 15 kilohertz. The bandwidth required as given by the Cartson rule is. Just apply the Cartson rule. We have a carrier frequency, message frequency, and frequency deviation. You are going too fast. Okay, we will wait for other response and 1 or 2 minutes. So just apply the Carson rule. We have all we have three data: FM, sorry, FC, FM, and delta F. What do you say? B or D? Okay, we will check. Miraj, what is the Carson rule? Okay, just use this formula. नहीं. Okay, so Minaj, I think answer is the B part. Okay, 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 okay. So that is the solution. We have a frequency deviation that represented by delta F that is given 50 kilohertz. We have a message frequency FM is 500 hertz. In kilowatts we can write 0.5. Okay, just apply the Carson rule. So it's a 2 delta F plus FM. Simply put the values, and from there we will get 100 kilowatts, 101 kilowatts. The answer will be B part. Is this clear? Okay, one second. Akila, it's clear. Akila Goli, Krishna sir. Okay, sir. Okay. So question number 3 is an FM modulation index is 9 is applied to a frequency tripler. So the modulation index in the output signal will be we are okay. So basically we have modulation index 9 and we are passing through a frequency tripler. Okay. So we have few terms like beta, FM, FC. So we got few changes when we applied with that tripler, doubler or whatever. So there in question number 3 they are asking what will be the modulation index when we pass through the frequency tripler. Okay, so answer will be D part, that will be 27. It's simple rule, and that is explanation, and that is when a FM signal is passed through the multiplier having a multiplication factor eta, modulation index of the output FM signal also get multiplied by factor eta. So initial beta is the 9, and we pass it through a frequency tripler, that will become 27. Okay, so if I change in question number 3, suppose we pass it is there we are talking about the modulation index. If we change it with replace with the about the carrier frequency, then what will be the output? And message signal, if we pass it, okay, so that point should remember. FM will not change, FC will change, beta will change. Okay, okay, so that is the question number 4. And question number 4 is, consider FM signal that is given there, the maximum deviation of the instantaneous frequency from the carrier frequency FCE. So there you have to calculate the frequency deviation, that is also denoted by delta F. Okay, so try this by using this, calculate the maximum deviation. Question 4 is clear now? Okay, try this. What we saying? Yeah, yeah, sorry, yeah, okay, okay. So please notice there will be beta 1 sine 2 pi f1t, and third term is beta 2 sine 2 pi f2t. If you solve without using the beta 1, so answer will become f1 plus b2 beta 2 f2. If you consider the beta 1, the answer will become a part. So please try. There is a typing mistake. Okay, so next we will go for the solution. Actually, answer will become a part, and that is explanation. So okay, this equation is given, and there will be beta 1. So we are talking about the maximum frequency deviation. So maximum deviation of the instantaneous frequency from the current frequency is called the maximum frequency deviation. So we calculate the maximum frequency deviation by using this formula. Okay, and on psi that term is represented by, okay, so we just apply the derivation differentiation of the, so just put there. Okay, so v1 sine 2 pi f1 to 2 pi f1 will come outside and will become cos 2 pi f1 t. Similarly there, or we are talking about the max term, the cos, the maximum value of cos we know it's will 1. So from there we will consider beta 1 f1 on the, and there will be got beta 1 f2, or 2 pi will be cancelled out. So maximum deviation is beta 1 f1 plus beta 2 f2. So answer will be a part. Okay, is it clear? Okay, so that is the question number 5. 5 is the phase response of a passband waveform at the receiver is given if pi f, it's equal to minus 2 pi alpha f minus fc minus 2 pi beta fc, where fc is the center frequency and alpha and beta are the positive constant. The actual signal propagation delay from the transmitter to receiver is. So there we have to calculate actual signal propagation delay, and we have a phase response. So try the question number 5. Question is clear, Minaz? Okay. Yeah, right. Okay. So can we go for solution? Okay. Answer will be a part. Okay. So Actually, we have a phase response that is given minus 2 pi alpha f minus fc minus 2 pi beta fc. It will be pi, okay? It will be pi. So we have to calculate the signal propagation delay. So again, apply the formula and differentiate this term with respect to f. Okay. So from there we will get minus 2 pi alpha f. For fc it will be 0. Similar for this term it will be 0 because we are differentiating with respect to f, not fc. So minus 2 pi will cancel out with this term. So alpha will be answer. So that is the phase response. Okay, so C part will be the answer. Okay, question number 6. An FM broadcasting radio system transmits signal of frequency 100 MHz with a power of 10 kW. The bandwidth of the modulation signal is from 100 Hz to 1.5 kHz. If the maximum deviation set by the FCC is 75 kHz, the range of the modulation index. Okay, so there we have to calculate the modulation index. We have a delta f, we can set the maximum deviation, carrier frequency, power, message signal frequency, which are vary from the 100 Hz to 1.5 kHz. Mhm. Yeah, FM is varying from 100 Hz to 1.5 kHz. We have a delta F, we have FC, we have a power. To calculate the range of the modulation index. Okay, I'm giving one or 2 minutes, then we will go for the answer solution. You are solving this question or you have answer? Okay, yeah, mostly question are formula based, so no problem. Other than Minas, anyone got the answer? Okay, so answer will be C part 50 to 170 750. So that is the explanation. Their message signal is varying, and we have a maximum frequency deviation is 75 kilohertz. Okay, so first we calculate the modulation index for the 100 hertz, then we will go for the 1.5 kilohertz. So just apply the formula beta is equal to delta f upon fm. So delta f is given 75 kilohertz and fm is the 100 hertz. So beta will become 750. Second, my message signal is given that having a frequency 1.5 kilohertz. Just put the fm in this formula. Delta f is a fixed, that is 75. Message signal frequency is 1.5. It will become 50. So their beta is varying from the 750 to 50. Okay. Hi. Yes, sir. In this question, we have no use of just information. So there we are not using any powers. We have no required. Okay, sir. Can we go for the next? Okay. So question number 7. 7 inch a signal mt is equal to 10 cos 2 pi 100t is frequency modulated. The resulting FM signal is we are getting xt is that is given 20 cos 2 pi 10 to power 6 t plus 15 psi 2 pi 100 t. The FM bandwidth is nearly. We have a message signal, we have frequency modulated signal. Calculate the bandwidth. Okay, apply the previous concept. From there we have a FM. Just write a general equation of the FM. From there you will get your answer. Okay. Okay, answer will be a part, that is 3.2 kilohertz. So that is explanation. Okay, basically we have a MT and we have a XT. So to calculate the bandwidth, we have Carson rule, that is beta plus 1 to FM. So we have required two terms, beta and FM. Okay, so FM is, we can get FM is from there, and beta. Okay, so beta is the 15, FM is the 100. So just put the values and you will get 1032 hertz. In kilowatts it will be 3.2 kilowatts. Okay, let's compare the xt with the general equation of the FM. Okay, AC cos 2 pi fct plus beta sine 2 pi fmt. I think you all know the general equation. So beta is the 15 and FM is the 100. Okay, the answer will be 3.2 kilowatts. It's clear. Okay, so question number 8. Question number 8 is the minimum value of the modulation index beta for an FM system required to produce a noticeable improvement in the SNR over a comparable AM system with mu is equal to 1 is. Basically, question is that we have to calculate minimum value of modulation index. Okay, for the FM system, जो which we can use. Okay, for an FM system which is required to produce a noticeable improvement in the SNR over a comparable AM system. Suppose we have a AM system which having a modulation index 1. Okay, and we are comparing with the FM system. For that purpose, what will be the modulation index, minimum modulation index we have required? Yeah. Hmm. Okay, basically I'm giving a hint. Okay, we have a modulation index. Okay, AM systems modulation index V is given, and we have to calculate the modulation index of beta in form of SNR, or we can say efficiency. From, if we compare the both, so from there you can calculate the beta for the FM. You have to compare with the FM system. So for the case of FM, efficiency or SNR. If we say the SNR of the AM system and FM system is the same. Okay, we'll see the solution. Okay, answer will be C part. So, okay, so that is the explanation. Okay, Hmm? Yeah, okay. Yeah, yeah. This is a new. Yeah, actually, this question I pick up from the ESC last year questions. Okay, so present time I have no derivation, but it's new, to, so I think we should discuss with you guys. Okay, so hmm, hmm, yes, sir. Yeah. So yeah, um, so we have as a mu of the M signal. From there you can calculate the beta. Actually, they are talking the minimum value of modulation index beta for an FM system required to produce a noticeable improvement in SNR over a comparable AM system. So that greater. Yeah, yeah. Okay. So it will come. It should be greater than 0.47. Let's, okay. Yes, sir. Comparatively. I mean, not too much, but I will tell you next class. Okay. I will go for it because surely I will discuss. Okay. Okay. I will. We will go for yeah. Okay. Question number nine. Nine is a for a PM. They were talking about a phase modulation for a PM modulator with a deviation sensitivity is k equal to 2.5 radian per volt and a modulating signal is VMT. The phase deviation M will be. In previous question we are talking about the frequency deviation delta F. There you have to calculate the phase deviation. We have a okay. We have a deviation sensitivity K. You can say KP or K, that is 2.5, and we have as a signal. Yeah. Okay. There we have to calculate phase deviation. We have master signal and deviation sensitivity, that is K. Actually, answer will become C part. That is the explanation. We have K, that is 2.5 radian per volt. We have a master signal VMT, that is 2 cos 2 pi into 2000 T. So peak phase deviation is For the frequency, for the phase modulation, it's kpam. That is the k, or we can say the kp is given 2.5, and am is the 2. So that will become 5 radian. Okay, it's clear. Okay. Okay, question number 10 then is, what is the modulation index of an FM signal having a carrier swing of 100 kilohertz, a modulated frequency of 8 kilohertz? Yeah, maximum 2 delta of, I think, maximum frequency. So from there you will get delta of frequency deviation. Okay. Okay. The answer is C part, that is 6.25. Okay. Basically the carrier swing is represented by the 2 delta f. Okay, that is 100. So from there we can get a frequency deviation, that is the 50 kilohertz. We have to calculate a modulation index, beta is equal to delta f upon fm. Fm is given 8 kilohertz. Okay, fm is 8, delta f is a 50, so it will be 6.25. It's clear. Okay. Okay, question number 11, that is, the signal mt is equal to sync 2 into 10 to power 3 is frequency modulated with the k is equal to 10 to power 3 hertz per volt. What is the maximum instantaneous frequency of the modulated signal when the carrier frequency is 1 megahertz? We have to calculate the fi for carriers, for the carrier frequency 1 megahertz. So try this. We have a kf, from there you can get am fm, fc is 1 megahertz. Yeah. Yeah. So let me check. I think it's sync. Wait. No, no. If it's sync, you just have to take the FM now. Sync T is sync X is you can write sync pi X upon pi X. I think it was sync. Baki, I will check it, but you just consider sync. Okay, just take the FM. Yeah, yes. You will see. Okay. Your time. Okay. Okay. I think it's a sync. Okay. Okay. It's a sync. That is explanation. Okay. We have a sync. Just took the FM. FM will become 20 kilohertz. It's right now. Okay. K is given 10. K is given 10 to power 3. That is also okay. We have carrier frequency 1 megahertz. And okay. 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 So we of the okay. Okay. Because it's a sinusoidal, na, we have to just take the message, the frequency of the message signal, not amplitude. No. Right. Well, yeah. So it will create no issue. Okay. So it was synced. Okay. So just put the KF max value of M and FC. It will become 1.001 megahertz. It's clear. Okay. Okay. Question number 12. That is a reasoning based questions. 12 is frequency modulation and phase modulation both produce different set of frequency bands for the same modulation depth. Next is the frequency modulation and phase modulation vary like carrier phase angle or its rate. Yeah. Are you sure? I'm saying, are you sure? Okay, we will check it. Okay, sir. I think I consider beta. Yes, sir. I think modulation depth is equal to modulation index. This term signify the modulation index. Okay. So explanation actually D part is the right answer. Is the false and R is true. Okay. Yeah. Frequency modulation and phase modulation both produce different set of frequency band for the same modulation depth and depth. Yeah. Okay. D is the right. Okay. Question number 13. It's also reasoning based question. Statement 1 and 2. FM spectrum consists of a carrier and infinite number of sideband components. Statement 2 is FM signal are used only in TV transmission to ensure better picture quality. Yeah. Okay. 13. C part is the right statement. Actually, we know that the FM spectrum consists of sex, carrier, and infinite number of sideband components. It's true. Next is the FM signal used only in TV transmission. It's wrong. For TV transmission, we use VSB, vertical sideband. Okay, to ensure the better picture quality. Basically, FM used for the audio transmission. We for the picture transmission we use the vertical sideband VSB. Which is okay. So that is the simple explanation. FM used for the audio transmission, VSB used for the visual transmission. Okay, question number 14. Consider a consider an FM signal with the instantaneous frequency FIT is given. FC plus KF AM cos 2 pi FMT. the modulation index beta of the FF signal. Direct formula. You already applied in last few questions. So, okay. So take your time. Question 14 is clear. Okay. Other than you, just no one is responding. Okay. The modulation index beta of FM signal is KFM 1 FM C part. It's just a formula for the FM signal to calculate the modulation index KF AM FM. Okay. Question number 15. Question 15 is a frequency modulated signal is described as XCT 10 cos 6 pi into 10 to the power 60 plus 1 by 4 sine 8 into 10 to the power 2 pi t. The approximation bandwidth of the XCT calculate using the Carson rule. Same in this question, just calculate the bandwidth, collect the information from the XT, beta, AM, FM, FC, and apply the Carson rule. Okay, we will check it. Okay, so answer will be C part 1 kilohertz. Basically, we have the FM signal that is given. We just have to apply the Carson rule, that is calculate the bandwidth, that is equal to 2 beta 1 plus FM. So just compare, that is a beta, that is given 1 by 4. From there you can get the FM, that is given, that is a 2 pi FM. So from there we will get FM, that is the 400. Put the values beta and FM, solve this, so we will get the 1 kilohertz. Is this clear? Okay, just is a general equation of FM signal. So answer is the C part. Okay. Question number 16. Consider a narrowband frequency modulated signal with the modulation index beta given as an input to a frequency multiplier by a factor of n. The modulation index of the output wideband FM signal. Initial questions we have the beta and we passing it through the frequency multiplier, frequency tripler. Now we have a frequency modulation is a beta and we are passing through the multiplier by factor of n. So please let me know the modulation index of the output wideband FM signal. What will be the modulation index? Yeah, we already solved this type of question. Question number 2 or 3. There we are passing through the frequency tripler. It has generalized question. Okay, answer will be A part. Sorry, sorry, it's a typing mistake. It will be A part. Okay, that will be n beta, not beta by n. It will be n beta. That is the explanation. Given narrowband frequency modulated FM signal with the modulation index beta given as an input to a frequency multiplier by a factor of n. Okay, so output will be we get in output we will get n beta. As we know, whenever we pass the FC beta from the frequency multiplier, it will be multiplied by that factor. So answer will be n beta. Ignore this term. Answer will be A part. Okay. Question number 17. That is a frequency modulated FM signal with a carrier frequency Fc is equal to 3 into 10 to power 8 is described by the equations. Find the maximum frequency deviation delta F. Again compare this equation with the general equation of FM. You automatically get all these values. Okay, that is the beta FM. Just use the formula of the frequency deviation. Anyone got the answer? Akhila? Usha, Ramesri. Okay, okay. So answer will be C part, that is 6 kilohertz. Just compare the general equation of FM with this, so from there you will get the beta, that is 6 FM 200, and we have a frequency deviation. We have to calculate the frequency deviation. So we know that the frequency beta is equal to delta F upon FM. So delta F is equal to beta FM. Beta is the 6, FM is the 1, so that is the 6 kilohertz. Okay, question number 18. A frequency modulated FM signal with a carrier frequency Fc, modulation index beta, and message signal is given. The instantaneous frequency of the signal is. What is the instantaneous frequency of the signal? Okay. Okay. Who give the answer? Okay. We will wait for 1 minute. After that, we will go for the solution. Okay. Answer is will be C part. So next, this is explanation. Okay, we have given an FM signal with the carrier frequency Fc, and message signal is given AM cos 2 pi FMT. As we know, the instantaneous frequency of the signal is Fc plus KF AM cos 2 pi FCT, cos 2 pi FMT. So no, so next we can calculate the modulation index. That is for the FM, it's a KF AM upon FM. Okay, so we can write the KFM in the form of beta FM, so that will be beta FM. So just write the place of that beta FM, that so it will be Fc plus beta FM cos 2 pi FMT. Okay. Okay, question number 19. Journal formula. Consider an phase modulated signal that is given. The modulation index beta of the signal is. Last I think question number 14 or 15, we are talking about the modulation index of the frequency modulated signal. There we are talking about a phase modulated signal. So yeah, yeah. Actually, we solved the one numerical now directly for the phase modulated signal. Yes. Okay, we will know not waste too much time. So answer will be KPA. That's a direct formula to calculate the modulation index of the phase modulation. Okay, from just the comparison you can get the KP for from the equation. Okay, question number 20. Consider the FM signal with the frequency deviation delta F and modulation index beta. The approximation bandwidth of the signal from the Carson rule is given as. Okay, please try. Okay, again recheck. Answer will be not A. Please check it once. Check your notes. I think sir drive these formulas. Answer will be part. So it is a formula, the approximation bandwidth of the signal from the Carson rule. From there you can calculate the bandwidth for the high values of beta and low values of beta. You have to do some approximation. I think lecture number please follow the lecture number 33 where sir discuss all these things. Answer will be A part, sorry, B part. Okay. Okay, question. Next question is: consider a parallel resonant LC circuit with L equal to 2.5 millihenry and the capacitance of the variable capacitor is given as CT, where MT is the message signal which varies slowly. What is the approximate center carrier frequency of the resulting frequency modulated signal? Question is clear? I have to check it. I think we will see it. Okay. What is the right answer? We have again. I am repeating the question. We have LC circuit. L is given. Capacitance, basically capacitor is vary with respect to the message signal. So what is the approximate carrier frequency of the resulting frequency modulated signal? Condition is given. Message signal is varying very slowly. Okay. Answer will be D part. And that is the explanation. Okay. So there, uh, the assume let C naught is the 10 microfarad. The output frequency of the parallel resonant circuit is given as 1 upon 2 pi under root L CT. T is the bearing. Okay. So just put the initial values. CT is given 10 microfarad minus 5 into 10 to the power 7 MT. Okay. Just use the approximation. Okay. So it is a form of 1 plus nx, 1 plus 1 minus x upon n. So you can write it 1 plus nx. Okay. So it's become that form. You can more simplify. You just multiply that term with the 1 and 0.00 to 5 mt. Okay, so that is a fc, that is a kf. So from there we can get the fc 2 pi, l is given 2 point, l is given 2.5 millihenry, c naught is 10 microfarad. Just put that. Okay, that is a fc plus kf mt, that will come 1 kilowatts. It's a little tricky question. Okay, they're talking about a parallel resonant circuit. So using that, we have to use the basic concept of that. So that will be 1 kilowatts. Okay, question number 21. A frequency modulated signal is described. The approximated bandwidth calculated using the Carson rule. We already used the formula of the Carson rule. It's applied here. Okay, that was the formula. Approximated Carson. Use that. Question number 21. Tell me the approximated bandwidth. Okay. Okay. Answer will be C part. Just compare and find the value of beta delta f. Okay, that is a given. So from there beta is a 2, fm is the 1500. Put this the values. Okay, I think there is a typing mistake. 2 beta plus 1 fm होता है. Okay, there is a typing mistake. 2 beta plus 1 fm. So that will become the 9 kilowatts. Okay, and that is the last question of today's class. That is, a given phase modulated signal has a maximum frequency deviation of 50 Hz for an input sinusoidal of input amplitude and frequency of 120 Hz. So determine the required frequency multiplication factor to produce a maximum frequency deviation of 20 kHz when the input sinusoidal has a unit amplitude and frequency of 24 Hz. So there we have to find frequency multiplication factor. Okay. For the rest. Okay, so we have a frequency deviation and frequency of the message signal. To use this data, so from there you can calculate the beta. Again, recalculate. From there we will get the frequency multiplication factor. Okay, so B part and the answer, that is at 200. Okay, so according to question, given phase modulated signal has a maximum frequency deviation 50 Hz for an input sinusoidal of input amplitude 1 and frequency is the 120 Hz. So from there we can calculate the frequency deviation. We have a frequency deviation 50 Hz. So from there we can calculate a Kp, that is the Kp AM/FM. Okay, that is a 50 by 120. Let frequency multiplication factor be n. Resulting frequency deviation is 24 kilohertz. 240 hertz. Put the values. Solve this and we will get the n, that is the 200. It's clear? Okay. Okay guys, I need your feedbacks. Okay. Okay. Okay, I'm planning. I'm making a PPT on few MATLABs. So one class I will in one class I will take all the modulation schemes. So it will help you all. Okay. Rest. Okay. 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 Next I will try. Okay. Minaj, you can type your mail ID, so it will better to communicate. Okay. If anyone. Okay. I am typing my mail ID, so you can mail me and if you have any doubt. Yeah, you have any suggestion, I will consider. So if you all have any doubt, you can mail me. I will try to answer. Okay. So I think we can close this session. Thank you. Thank you all. Thank you all for joining this session. Thank you. Okay.